I said then later on the definition of reciprocal and then the notion of inverse came into play. So people start representing what is a half and then what is a quarter and so on and so on, a fifth and so on and so on and so on and so forth. And then the division came into place. When you have a cow, you slaughter it. If you want to divide the meat, you can divide it into so many portions to so many people. And then these notions kept continuing that one cow can be slaughtered and then divided in two, or one goat and so on and so forth, or divided in three or four, depending on the number of people. Then a new set has taken place, which is called the set of rationals. So they define this and they call them rational because to rationalize, to take something and you divide it by something. And then that set of rational is given by this letter Q. So the set of rational, it takes all the negative integers. You can also have the remaining numbers, but however, if you start writing it like this, like let's say with minus half, that means that you cannot write all of them like minus 1/3, minus 1/4. Then the question is that since we cannot represent it using the same technique as we represent the integers, how do we represent it? Because it got all, yeah?
You've reached the 7-minute mark.
Or the previous discussion has stopped, so now I'm in a new one. So then,
Okay.
then there's, because the definition now has taken a different shape. You can call it A divided by B or P divided by Q, with A and B both integers. They can be positive and they can be negative. It doesn't matter. However, because B is in the denominator, you cannot take something and you divide it by 0. So because you can say I have nothing. I have something and I'm going to divide it to no people or to no one. So then you have taken B different from 0 in a knowledgeable sense. Then that gives us the set of rational numbers. And then later on, thanks to Euler and all the other discoveries, then some new numbers came into play. Some numbers they decided to actually try to check how all these numbers are represented in the form A divided by B with B not 0. And then they have discovered that thanks to the measurement of the pyramid, that there are some specific numbers that they are not able to get them correctly. And then because of that, then a new notion has come into place where Euler and all the other colleagues, and they have discovered, and all the other scientific, that there are some numbers that they can represent by pi. There's a number that they don't end after you divide them. You can't get the end very easily. So this is, let's say 3,14, and then going. And then they represent those numbers by pi, 3.14 and so on. So 214, so on and so forth. They started representing those, and then thanks to Euler also, then there is a letter U, which is close to 2.7718 and so on and so forth, or 28. So then they said, okay, these numbers that we call rational, they don't include these ones because they struggle to represent some of these numbers in that rational form, because they can't get the exact numbers to get to these ones. Then the idea was that then these ones, because they can be represented in a form of rational, but they are not real rational. So then they call them irrational, and irrational started with an I, so which is contain the numbers that are not rational. But then there was no, because they are division, and if you represent them by the division, you confuse them with the set Q, because the Q is the one having the numerator and the denominator not being a 0. Now, the numerator, what I mean by numerator is the one on top, the A here, and denominator is the so that is the numerator, and denominator is the B. So that's in a sense. However, then the question is, how do you represent this one? So you can only call them, and we cannot represent them. So then there's a new notion that says, okay, we can try to figure it out. So I will come back to this one just now. Let me see here. Now, if then all of them, including those ones, they're represented by a set called R, set of real numbers. So then the question is, we have the set N of integers. Outside the set N, we have the set Z of positive and negative integers. Outside this set, there is the set Q of rational numbers. Now the question is, what is the relation between N and Z, and then Z and Q? And then outside this, there is the set I of irrational numbers, which doesn't fit and somehow. Then the one that is having all of them is the set R. So I'm going to keep the set of the irrational numbers out. Then we have what called the set of real numbers, which is usually they call it the set R. And then there's something else that I'm going to give it later, which is called the set of complex numbers. So I'll keep that one for now. Now the question is, what is the relation between all of those? So there is N. And then if you take the set of natural number, you take its complement. So which means that you get Z. Z basically is the complement of N. So which means everything that is inside N and outside it also Z. So but then, however, this notion, it's much appropriate to now represent the set I that I left earlier on there. This set I is going to be the complement of the set Q. So which means there are those divisions that are not in Q. So it's called the complement of Q. So C stands for complement. So yes, is it already 7? Okay, let me save and then let me stop. Thank you so much for that. Then I will start again from scratch. Thank you for that. Please keep reminding me of each the 7 minutes, and then at 10 I must stop. Okay, we have already reached 10 o'clock.